Hello everyone, welcome to today's GCSE Maths lesson on interpreting graphs in simple steps. Graphs are everywhere in maths, and being able to read them, analyse them, interpreting them is a key skill for exams and real-life applications. So let's break it down step by step. Let's get straight into it. Right, we have different types of graphs. Let's go through the different types first, so you're familiar with which is which. A bar chart is where we have something that looks like this. We have bars, as we can see here, and they compare discrete categories. So here, what we're looking at is whatever information this represents. So we have the x-axis down here, which represents the days of the week, Monday to Friday, and then we have a number of miles. And then we have two sets of data for two different individuals, Paula and Rose. And what we're looking at is the number of miles, so we need more context here, but the number of miles they ran or worked or walked in a week, in a day, it doesn't matter. But that's the number of miles, and they walked different days. And notice how we're missing Rose's information for Thursday. That's probably what the question was asking. But we have discrete categories that are represented by different bars. A line graph demonstrates a specific trend over time. We're looking at days of the week and the number of books sold, but it represents a specific trend over a specific period of time. Pie chart, as the name suggests, looks like a pie, and it represents data as proportions. So we have, for example, a quarter of our data is represented by transport. Whatever this is, again, we don't have the context of this question, but this could be how much a person spends on different categories within a month. So a quarter is spent on transport, and then we have different proportions that represent food, entertainment, rent, and bills. Scatter graph shows relationship between two variables. Our variables here are height and arm length. So, and what we're looking at here is as the height increases, the arm length also increases. So it represents specific data collected between two variables, where two variables are being investigated, commonly used in science as well. A histogram displays grouped continuous data. So we're going to look at all these different types of graphs and look at how we use and interpret these, so it makes more sense. But just wanted to introduce what they look like and how they're represented. Now, how do we read graphs? So the most important things to look at are basically the x-axis and the y-axis, identifying what they each represent. So if you have something like this is the x-axis, always and always. The horizontal is your x-axis, the vertical is your y-axis. Now, what does the x-axis represent? What does the y-axis represent? The two things we're comparing, or we're looking at, and then looking at the scale and the intervals, and then being able to read the titles carefully and spotting patterns and trends. So if we're looking at, for example, this graph, looking at the scale, it's going, so from here to here represents 1. So whereas you have a graph like this, where from here to here represent 10, but it starts from 120, goes up to 130, and so on. If we go back here, we don't have the x-axis represents the number of days, not specific numbers. So paying attention to our x-axis and then paying attention to our scales for the x-axis and the y-axis. So on the y-axis here, we're starting from 50, it's going up in tens. On the y-axis here, we're starting with 0 and it's going up in ones. On the x-axis here, we're starting with 6, it's going up in tens. But looking at what do each of these small little squares represent could be different. So what intervals of the graphs as well, and then spotting patterns. Let's look at some specific examples. Okay, we have a bar chart here. Here's a bar chart showing the number of goals scored in a game by a football team in a season. What is the modal number of goals? First question. Second question says, look at the number of goals that were scored in total by the team. Okay, so we have a bar chart. We have frequency against the number of goals. So the x-axis represents the number of goals, the y-axis represents frequency. Now, let's look at what each bar is telling us. So the first bar is telling us that 7 games ended with 0 goals. So 7 games had 0 goals. Now, next bar is telling us that 8 games had a total of 1 goal, right? If we multiply 8 by 1, that means a total of 8 goals were scored across these 8 games. Next one is telling us that 12 games had a total of 2 goals. So if we do 12 times 2, that means these 12 games gave us a total of 24 goals, right? So that's what we do to find the total number of goals. And 3 games gave us a total of 3 goals, which is 9, and 6 games gave us a total of 4 goals. So 24 goals. Now, if we want to know the modal number of goals is the mode, one with the most frequent occurrence, the one that repeats the most, the one that happens the most. So 2 number of goals was the one that occurred the most. So the modal number of goals is 2 here, right? Now, to find out the total number of goals that were scored across the team. We found out how many goals were represented by each bar. To find a total, we're going to add all of them together. So 8 plus 24 plus 9 plus 24, and the 0 there as well, but obviously it doesn't change our number there. And that gives us 65. Right, now we're looking at a line graph. So it says below is a line graph that shows the population of a village. So x-axis represents the year, y-axis represents the population. What was the population in 1980? Okay, we find where is 1980 over here, and we want to know the population. So use a ruler for this. So 1980, then we go up to the line, and then across to the population, which is that one there. Right, then we look at the intervals. So we're going from 650, so one big square represents 50, which means 60, 70, 80, 90. So every single one of the tiny squares represents a 10, number 10. So that means that if that's 750, that's 760. So the population was 760 in 1980. In which year was the population 700? So then we go to the axis that represents population in this case, which is here. Then we go across to our line and down. It's year 1970. So pay attention to your axes. Here we were asked about what the population was in specific years. So we go down to the axis that represents the year, and then we go up to the trend line and across. Second question, we were asked about what year it was with a certain population, with a specific population. So we go to the population, the y-axis which represents the population, and then we go across and down. So pay attention to your axes and which one you need to use. Now, third part of the question says the population is expected to increase by 120 by 2020. Work out the expected population in 2020. Okay, so that means we look at what is the last population that's given to us on this graph, and we can see that it's right here. So it's 990. If it's expected to increase by 120, we just add the 120 to this, and we get 0 plus 0 is 0, 9 plus 2 is 11, carry the 1 over, 9 plus 1 is 10, plus that is 11. So in 2020, we expect the population to increase to 1,110. Right? Hope that makes sense. Let's continue. Okay, a pie chart. Let me put my face over here. The pie chart shows information about the favorite pizza topping of a group of students. Use the pie chart to complete the table. Right, okay, so let's look at this. So we are told that the number of peppers, so the frequency represents the number. So peppers is represented by, if we look at the angle here, 90 degrees. And the 90 degrees represents 18 individuals. So from that, we can find out how many degrees represents one person. And then from there, we can go forward and find the rest. Now, the one thing to know with pie chart is it's a full circle. So you're going round a point. So it's 3. So the whole pie chart represents 360. So when we add all of these together, the angle at the end, the total angle should always be 360, right? That is a quarter. So we have the quarter of the numbers. If we knew the total, we'll divide it by 4 and find a quarter. But we also know it's 90 degrees, and we're also given its frequency. So we can work backwards to find the rest. So if we want to know 18 individuals is represented by 19 degrees. So 18 people, what would one person, how many degrees would one person represent? So to do that, we think of it like this. To go from 18 to 1, we divide by 18. We're going to do the same thing here. We're going to do 90 divided by 18, and that gives us 5. So one person is represented by 5 degrees. Now, so that means if we go through the rest, ham is represented by 40 degrees, according to the question. Mushroom is half a circle, straight line, so that means it's 180 degrees. And pineapple, so ham and pineapple all together should add up to 90 degrees. As we know, a quarter of a circle is 90 degrees. So if we do 90 minus 40, that gives us 50. So the angle for pineapple would be 50 degrees. So now that we have the angles for all of them, we can find out the number. So if one person is represented by 5 degrees, then we can look and see how many people would 180 represent. So to go in this direction, we divide by 5 for all of them. So if we do 180 divided by 5, that gives us 36. 50 divided by 5 gives us 10. 40 divided by 5 gives us 8. And that's how many people each of these proportions represent. I hope that makes sense. Let's keep going. we have a scatter graph. On a particular day, a scientist recorded the air temperature at 8 different heights above sea level. The scatter diagram shows the air temperature Y, centigrade degrees, at each of these heights, xk kilometers above sea levels. Okay, so we have the x-axis represents height above sea and the y-axis represents the temperature. Let's look at the questions we have down here. It says, using the scatter diagram, write down the air temperature recorded at a height of 2.5 kilometers above sea level. Okay, so we need the temperature and we have the height. So we go to the axes that we have the information of, which is the height, the x-axis, and we go to 2.5 kilometers. So this is 2.5. And then we need to know what the temperature was. Now notice, remember what I said about scatter graphs. It represents relationship between two variables. However, in order for us to use the data to estimate, we need the line of best fit. So we're not going to connect all of these lines like a line graph. But what we are going to do is we're going to grab a ruler and draw line of best fit. Now, line of best fit would look something like this. So it's a good representation of the data, and it's not meant to go through every single point, but it's meant to be as close to as many of the points as possible, and that's what we mean by line of best fit. Now, so the first question asked us to find the temperature at 2.5 kilometers. So we have the information for kilometers, we go to 2.5 and then across. Here we have a point at 2.5 anyways, so if we go up at 2.5 and then across, again, please use a ruler for this, we get to 2. So it's 2 degrees. At 2.5 kilometers, the temperature is 2 degrees. Describe the correlation between the air temperature and the height above sea level. Now, correlation means what happens to one as the other one increases or decreases. So what's the relationship between these two? So as the height above sea level increases, the air temperature is dropping, the air temperature is decreasing. So if as one increases, the other one also increases, we have a positive correlation. So anything that looks like this is a positive correlation. If we have anything that looks like this, which is what we have here, it means as one increases, the other one's decreasing. And that is a negative correlation. Find an estimate of the height above sea level when the air temperature at 0 degrees. Okay, so that means at 0 degrees, we want to know the height. So we're going to extend this line, our line of best fit. Can please use a ruler. And we're going to look at, so 0 degrees, the line of best fit goes through somewhere here. So let's find out what the interval is. So from here to here, we have 0.5. So that means every 2 of these tiny squares represents 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5. So that means that's 2.6, 2.7, 2.8. So it's 2.8. We're estimating that it will be 2.8 kilometers at 0 degrees. Now, the reason why it's an estimate, because we are using a line of best fit, which we think, a line that we think best represents data. Now, your line of best fit might look a little bit different to my line of best fit, which is why there is a range of data that may be, a range of answers that might be acceptable, but it's an estimation nevertheless, right? It's not an actual data that was collected on that point at 0 degrees. Right. Histogram. Okay, below is a histogram showing information about the weight of parcels. We've got the frequency, density, and the weight. It says use the histogram to complete the frequency table. Now, so frequency density is represented by dividing the frequency by the category, whatever category you're given. Right, so to find the frequency, we're going to multiply the frequency density by the range of the weight for that particular category. So for the first one, the frequency, so we need the frequency density, which we're going to get from the histogram itself. So the first one has a frequency density of 10, and we're going to multiply that by the range of the first category. The range is 0 to 1.5, so it's 1.5. So 1.5, multiply that by 10, and that gives us, so if I write it here, 1.5 times 10, and that gives us 15. So 15 parcels had the weight between 0 to smaller or equal to 1.5. For the next one, the range is 1. It goes from 1.5 to 2.5. So the range is 1, and we're going to multiply that by the frequency density represented for the second category, which is 15. So 1 times 15 gives us 15. So again, 15 parcels had the weight greater than 1.5 or smaller than equal to 2.5 kilograms. Next one, the range is 0.5, and the frequency density here is 16. So we're going to multiply that by 16, which is basically halving 16, which is just 8. The next one has a range of 1.5. So we're going to multiply 1.5 by the actual frequency density, which in this case is 12. And that gives us 18. then the range is 1.5 again, and we are multiplying by 6, and that gives us 9. Right, and I just realized I made one mistake. So if you go back here, that value there is not 16 because so I made a mistake with my intervals. If this from here to here is 5, that means every 2 of these squares represents 1. So that would be 16, 17, and that would be 18. So that should be 0.5 times 18, which then gives us 9. Right? Hope that makes sense. Let's move on. Right, let's look at some common mistakes to avoid. Right, so most common mistakes would be not reading the axis labels carefully and not recognizing what do the x-axis and the y-axis represent, or ignoring the scales and intervals. What is it going up in? Like the mistake that I just made. It's very easy to make. What is it going up in? And not using rulers and straight lines to get the exact answer that we're looking for. So interpreting the numbers we're looking at. The other common mistake with pie charts specifically is where you misinterpret percentages that are used in pie charts. So if we have a quarter of a pie chart, that's 90 degrees. That also represents 25%. So we use percentages and we use number of degrees. So 360 represents 100% because the whole circle, the whole pie is 360 degrees. So be careful with that. And then also not identifying the correct trend in line graphs. Am I using a line of best fit for a scatter graph that I'm using? Have I drawn that curve properly? It's not a line graph where I just connect everything. Scatter graph means the data are scattered everywhere. So I'm going to use a line of best fit to represent that data. However, if the data is absolutely everywhere, that means there's no trend. There's no identifiable relationship between the variables. So be very careful with that. Right. Great job today, well done. Today we explored different types of graphs and how we can interpret them. We are going to do a different lesson on how we can draw them and how we find information that we need to draw them, but today was just about interpreting them. So well done for that. Keep practicing and soon you'll be able to analyze, identify trends from graphs confidently. If you found this to be helpful, please like,